A structural diagram of the Bragg grating is shown in Figure 1. The measurement process consists in generating a broadband optical signal and registering the narrow part of the spectrum reflected from the grating. The quantitative characteristic of the reflected radiation is the wavelength at which the maximum power of the optical signal is achieved. This characteristic is called the central wavelength of the grating. Two optical signal spectra are shown in Figure 2. Spectrum 1 corresponds to the grating in its initial state, spectrum 2 corresponds to the deformed one. The displacement of the central wavelength depends on temperature and deformation. The construction of a sensor based on the Bragg grating requires an accurate determination of this dependence. As a rule, a linear approximation of this dependence is used. The first two terms of the expression 1. In this paper, all the terms of the quadratic expansion are defined and their contribution is shown. The results were obtained on an experimental setup. Her photo is shown in Figure 3. The setup allows you to set the fiber deformation and temperature. As part of the experiment, 3 values of deformation with the help of loads are set. A stepwise temperature loading from 5 to 100 degrees Celsius with a step of 5 degrees is performed for each load. An example of a stepwise change in temperature and the central wavelength of the grating is shown in Figure 4. The change of the grating wavelength from temperature at different values of elastic deformation is shown in Figure 5. Using the least squares method, the approximation of the dependence of the wavelength on temperature and deformation is performed. On the basis of this dependence, the coefficients of decomposition 1 are calculated. They have values 2. The contribution of each term of expansion 1 at temperature 100 degrees Celsius and strain 2500 microstrain is evaluated as 3. The contributions of the summons with respect to the first term of the expansion are expressed in percentages as 4. The parentheses indicate the belonging to the corresponding term of the expansion. It follows from this expression that nonlinear terms have a significant contribution.